This is a video for OCR Pure Core Mathematics, Calculus 3, Integration using Partial Fractions, 3.5, Integrating where the denominator has a quadratic factor. We've seen in previous videos that it often helps to rewrite the integral of an algebraic fraction in partial fractions. The integral can then be split and handled as two or more separate integrals. In the case of quadratic factors, you may end up with more than two integrals, and one of those may be an arctan x type of integral. Let's look at this example. It's the integral of an algebraic fraction. I've got a quadratic factor on the bottom here, and just doing a quick check, the numerator, top line, is of a lower power than the bottom. We've actually seen this algebraic fraction before and have already split it up into partial fractions in a previous video. So this thing turns out x squared plus 3 to be this in partial fractions. It's 1 over x plus 1 plus 2 minus x over x squared plus 3. So my integral, x plus 5 over x plus 1, x squared plus 3, is just the integral of these bits. There's the first bit, 1 over x plus 1. And I'm going to just play about with this a little bit. I'm going to take minus x over x squared plus 3 plus 2 over x squared plus 3. So that's just splitting the top line here, so I get 2 bits to the fraction. Integrating the first bit, I'm going to get the log of mod x plus 1. This second one is also a log. If you look at the top line, it's essentially the derivative of the bottom. It's actually a half of the derivative of the bottom because the derivative of the bottom would be 2x. So I'm going to get minus a half log mod x squared plus 3. And then for the last one, think of this as 3 plus x squared rather than x squared plus 3 on the bottom, and you can see that what I've got is actually an arctan type thing with the a in the a squared plus x squared being root 3. So I'm going to get 2 over root 3, that's 2 over a, arctan x over a, so that's x over root 3, and I'm going to get a constant of integration on the end. Now, as before, we can combine the logs together. This minus sign means I'm going to get a divide, and the half means this thing is going to be square rooted. So I'm going to get the log of mod x plus 1 over the square root of x squared plus 3. And then I'm going to get the remainder of my result, 2 over root 3 arctan x over root 3 plus c. There's that tidied up. Here's the partial fractions result from an earlier video. This is splitting that up into separate bits to integrate. There's the integration being done, and there's the final result. So in summary, we would check that the denominator is a higher power than the numerator. If it isn't, we've seen previously, we'd do an algebraic division. We then split the algebraic fraction into partial fractions, and then we can split the integral and handle each bit as separate integrals. It's worth noting that in the case of quadratic factors, you may end up with more than two integrals, and you may well end up with an arctan x type of integral. Remember, if there's more than one log, they can be combined, but it's really only worth doing if the coefficients are relatively simple. That was the final video in the sequence Calculus 3, Integration using Partial Fractions.